Alright guys, Horizon Zero Dawn is out for the PC. I don't know anything about it. I haven't really seen any gameplay of it. I know it's a third-person action game, and so it's time to Omnify it. Let's hack the fuck out of it. So, as we always do with games that we want to Omnify, we're going to disassemble the most important data structures in the game, study them a bit, and then write some code to grab these data structures for our player. The first thing I'm interested in is a root player structure for my character. Aloy, I think her name is. A root player structure is where all data related to the player can be found, such as the health, coordinates, experience levels, etc. Sort of an identifying bit of glue we'll be using to identify the player when hooking into various functions. The easiest way to get the root player structure is typically by figuring out where the player's health is. So we're gonna do that right now. I can see my health up here in the upper left corner. It is 250. Now, even though the health cannot be expressed or displayed to us in this game with a decimal point, I'm going to assume that the data type here is indeed floating point. If this were a Japanese-made game, they'd be storing the health as a 4-byte or 2-byte integer. This is a non-Japanese game developer, however. Therefore, it is stored as a float, even though there's no reason to, really. And I bet I'm right. So, to find the health, let's do a search for all floats that are at 250. I'm going to change my value type to float, do 250. For scan. All right, we got 11,000, which is not terrible. Let's take some damage then, and then search for the updated value. 185 it went to, so search for values of 185 next. 16, okay, let's take some more damage. 120. Now we just have two values here, great. So let's figure out which one is our actual health here. We'll be manipulating them to various values and see when it updates in the game. So 130, nope. Probably this one then. As you can see, if you look up there, my health did update to 130. This is the real health value then. So this is health. Okay, so now that we have this, how can we figure out where the root player struct is? Let's see what code is reading this value right here. All right, we have one function consistently accessing my health, even when the game is paused. I suspect there'll be additional functions when the game is unpaused. You can see it's accessing it with a offset of 64. That's where the health value is. So either the root player struct might be here where RAX is pointing to, or it might be a health struct that can be found on our root player struct. But then hopefully a pointer to a root player struct can be found in this health struct. Let's take a look then. I'm going to copy the RAX that's over here. We're going to open up structure dissect. Okay, defining structure. So this structure is called destructibility, which is interesting. I suppose this is then basically a health struct. This is a struct describing something that can be destroyed, something that has a condition. So we saw here, 130 is my current health. So this is our current health here at offset 64. And this looks like a maximum health here, because that's my health as it is when we max it out. I'll leave that as a question for now. We have a destructibility resource struct here, interesting. And we have a soldier struct. This looks like to be a player root structure to me. Let's take a look at it real quick. AI entity humanoid. Can we find our destructibility here? Yes. So it looks like these soldier structs are what describes the player at the root. I'm just making that determination now because we have a whole bunch of things related to the player. We have their model structure right there, which is nice. Hopefully we have some kind of coordinate here for the player as well, somewhere, and we'll take a look at that. But it looks like here is where we can grab the player's health and their root struct, which is what we need. So let's see if there are any other functions that are calling or accessing the player's health when the game's unpaused. Okay, there's one additional one that's accessing the player's health when the game's unpaused. We want to see how many addresses these functions are accessing. Let's just take a look at the one that's running when the game's paused. This is only accessing one address mine, which is good. However, because we do have one enemy by us, but maybe it'll act differently when we're by humans. Who knows? Let's look at the other one. This is accessing me, my value, and this, I assume this is the enemy that is attacking me, is health value. So a little less useful for us, but one of these we will hook into. So let's write the code up to grab the player's health struct and the root struct now. It'll be handy to have pointers to both of these structures. All right, here we have prepared a hook into the second of those two functions that we were looking at. After some further testing, I found that it was much more reliable for getting just the player struct with the right filters put into it. I guess the only downside is that it doesn't grab the player struct for us until the game is unpaused, but that's not a big deal at all. So the goal here is we want to get the player's root struct, and we want to get a pointer to their health as well, their health struct, that destructibility struct. A lot of struct talk going on here. The original code here is, as you can see, just a read from the character's current health. So let's push the conditional flags and then restore those conditional flags. We're going to be doing some comparisons here, and we don't want to screw up anything. We're going to allocate 2 pointers here. We're going to allocate a pointer for the root player struct here, and then we're going to allocate a pointer for the player's destructibility struct. Let's register these two as symbols. Then let's clean them all up. Down here in the disable part. All right. So after some playtesting of the game, I found that we first want to isolate just the player struct here and from anything else, and other things will pop up here. And one flag that I noticed, one register state that helps us out do that a lot is looking at that RBX register. And if the RBX register is 0, then it's much, much more likely that we're looking at the player's data here. And so we want to compare RBX to 0, and if it's not 0, we want to get out of here and not set any of these pointers. And after some even further additional playtesting of the game, I found that when humanoid enemies get close to the character here, that they'll start showing up. They'll get past this filter here. They'll sometimes have an RBX of 0, and it'll start to confuse what's the player and who's not the player. And the way I filter that out is by looking at the R13 register and seeing if that's 0. If RBX and R13 are both 0, it's guaranteed then that it's the player we're looking at. And I discovered this just through play testing and experimentation. So if it's not 0, R13 that is, then we want to also get out of here. Otherwise, we're good to go. We're gonna back up 2 registers here, not RAX, because we need to use that. That contains the current destructibility struct, but we'll back up RBX and RCX. Restore them down here. We're gonna move to RBX the address of the player health struct here. Then we're gonna dereference that, and we're gonna have that point to RAX, which is where the original code is reading the health from. So RAX is essentially our player's health struct. Next then, if we remember looking at that dissect structure window, we could find that soldier struct then at an offset of 48. So let's move to RCX, RAX plus 48. So RCX now will point to the player's root struct. We're gonna move to RBX, the address of the player root struct pointer. And we'll dereference that and have that set to RCX. So now we have both the player and player health structs properly initialized and set up here. So we'll save that. Let's load it up and then see what we got. All right, got it loaded up. Okay, it injected just fine. Let's unpause it a little bit. Didn't crash, great. Just add a pointer for our player's health here. So player health. And then I think it was 64. Looks like this works. Great, 130. Wonderful. So we always have our character's health here in our code, and by extension we have their player struct as well. So let's take a deeper dive then at the player struct, see if we can't get the coordinates, figure out where that is. Also learn a little bit about the data structures of this game. All right, now that we comfortably have the player's root struct, let's take a look at the various data structures in this game and how they work. So I'm gonna load up my structure dissect window here, and I'm gonna just type in here player, because this is our pointer that we created in our code. And we can load up that soldier struct, and here's our player's root structure. And again, we can find the destructibility struct for the player and their health and all that at offset at 1F0, which is useful. So I've been looking at the game for a bit and how coordinates work. And this game has a somewhat complicated movement system and location coordinate system, and complicated in the sense that it's quite varied among the various denizens of the game. Maybe I'll go into it more during the Predator implementation video that will be soon to come. But as we can see right here, starting at the offset E0, E8, EC, this is the coordinates for the character, and not just the character. This is where you can find coordinates for humanoid entities, NPC, of course, and non-humanoid creatures. And this is their de facto source of truth coordinates. They are stored as doubles. However, they are not for the player. They are not their source of truth. Source of truth meaning that if I, add it to my address list here, and if I froze it, I wouldn't be able to move, because if it was the source of truth, then this is what everything else bases their understanding of where the character is on. But if I try to freeze the character here, I can still move. You see some flickering, right? Like, it's remembering that one position maybe that I did freeze, but it's not the true source of truth. I wouldn't be able to move if it was the source of truth. It's some other auxiliary function or purpose. Now, if Aloy was an NPC, it is a source of truth for NPCs, humanoid and non-humanoid. That's quite confusing. I found to actually find the character's true coordinates, this is the root structure again, we actually have to go all the way down to offset 808, which I will get to eventually, to look for a capsule component. This is starting to get into Havoc physics stuff, I think. And inside capsule component, we go all the way down to 180 to the character proxy. Once inside the character proxy, if we look at offset 70, these are the true character's source of truth coordinates. And they're stored as floats this time, not doubles, which is confusing, that they have two different data types they're using. For anything that's not the player, doubles are what are used, but for the player, it's floats. So just to prove it, we're gonna add this, and I'm gonna check it, freeze this one. And as you can see, I can't move. This is a true source of truth coordinate here. Now, this character proxy, though, does not exist for the other creatures, or at least not in a way that I could find easily. I mean, indeed, their source of truth is that one E0 offset. So this complicated a few things at first because I have to handle them differently, in a sense. It's kind of a pain. And not only that, as you'll see in the Predator video, the area where it calculates or actually applies the offsets to coordinates when it's updating them is different for creature versus humanoid versus non-humanoid. So another complication here is that I also observed that this address is not always here. That is inside this capsule component. The character proxy isn't always at 180. It's sometimes somewhere completely different, although the coordinate can always be found at 70. That's a bit worrisome to discover that at first. I thought I was dealing with a game that had ridiculous data structure standards or whatnot. I'm not sure. Most games, like, you can take for granted, at least in the player struct, where the coordinates are. Now, as you might have seen my polymorphic data video, certainly there are functions and there are data types where it's quite varied where data is, but it was very worrisome to see that. So anyway, we couldn't create a pointer to the player's coordinates and have them set up just always to point here, because we couldn't always guarantee that this is here. So we have to have a separate function that we hook into to get the player's coordinates, and we found this function just by seeing what is accessing these coordinates here and hooking into one of the polling functions, one of these here. And indeed, the one that we are hooking up into is the first one here, the one that's running the most. And here's the code for that. See, it just hooks into a function that is just basically pulling for the character's X coordinate. There's no filtering that's required here. This is only for the player's coordinates, nothing else. Which again made discovery of non-player coordinates kind of difficult, since I usually rely on the fact that, and it's usually true in most games, that functions accessing player coordinates are accessing enemy coordinates as well. Same with updates and all that. This is very simple. Just hooks into here, and sets my player coord's address here. Let's take a look more at the data structures here that we're gonna need to deal with. We have basically all that we need in order to implement the Omnified systems. I need to at least know the health of the player, and then how to get their coordinates. We're gonna also have to know how enemies work. Humanoid NPCs use a soldier data structure, and the non-humanoid enemies use one called creature. But they're, for the most part, the same. They have the same data at the same places. I'm sure there's some differences. Instead of soldier rep, it would be creature rep. Not too sure what humanoid mover would be. Non-humanoid mover, creature mover? I can't recall. Inside the destructibility structure, we were looking at this before. Remember that the current health here is at 64. We assume this might be the maximum health. It is not the maximum health after further experimentation. To find the maximum health, we actually have to go into the destructibility resource struct here. And if we scroll down a bit, we can see 2C here. This is the actual maximum health of the character. But you might be asking, well, it's at 200 and I have 250 here. So you might think I'm a liar. I'm not a liar, I swear. You need to actually return to the base destructibility struct, and you have to look at 70 here. And this is, or 74, sorry. And 74, that offset, we see a 50 here. And I do believe this is the health increase from leveling. So basically your maximum health is at values found in the destructibility resource at 2C, and then you add that onto 74, and then that's your max health. So if I actually want to increase my character's maximum health, if I change this, it doesn't do anything. This is a calculated value that's used in something. But I need to actually change this guy here. Let's change it to 374 offset. And that was discovered by looking at how the maximum health was calculated up above. And we figured that out by getting hurt and drinking healing potions and see when the healing would stop, basically. There's a whole bunch of other interesting little functions here, camera entity, interesting stuff we might look at if we need to. But for now, that's about all we need to look at and understand for the player in order to implement my Omnified systems. So we're gonna start implementing those Omnified systems next video. Hope you found that interesting. If you wanna catch the Omnified gameplay live when we're streaming this game, when it's fully Omnified and crazy and brutally hard, the only place you can do that is by catching my live stream on twitch.tv/omni. If you like this content here, if you learned something, if it's just something to relax to, the sound of my voice, I don't know, please give me a subscription, hit that subscribe button. I really appreciate that. It means everything to me. Like the video if you like it. Got any questions, you can leave a comment, I won't bite. Until next time then, see you guys.